geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this: at what distance above and below the surface of the earth a body will have same weight? It is like this. Let the surface of earth, surface of earth. Let us take a body at a height of h from the surface of the earth, where the weight equal to mg. Similarly, you take the same body below the surface of the earth, the same body below the surface of the earth. At a depth, let it be h, where the weight equal to mg. Assume the weight above the surface of the earth is w1 equal to m g1. Weight below the surface of the earth is w2 equal to m g2, because m remains same, because same body is taken above the surface of the earth and below the surface of the earth. Then at what height and depth from the surface of the earth w1 equal to w2? That is the question. Here w1 I can write as mg1 equal to mg2. This m is cancelling indirectly. At what depth and height g1 equal to g2? Okay, g1 is the acceleration due to gravity at a height at a height h above the surface of the earth, whereas g2 be the acceleration due to gravity at a depth h from the surface of the earth. Okay, for that let's take another slide. Above above surface of earth and below surface of earth. Above surface of the earth, the acceleration due to gravity we are assuming as g1 equal to gr square by r plus h whole square. This already we have clearly discussed. Whereas below the surface of the earth, g2 is g into 1 minus h by r. Okay. The g1 I can also write gr square by, let me write the r square outside, 1 plus h by r whole square. Then this this r square is cancelling. Finally, the g1 equal to g by 1 plus h by r whole square. Assume some x equal to h by r. Then I can write g2 equal to g into 1 minus x, whereas g1 equal to g by 1 plus x whole square. Now it can be written as g by, let us expand it with a plus b whole square, 1 plus x square plus 2x. Now let us equate these two. Here g1 equal to g2. g1 I got g by 1 plus x square plus 2x, whereas g2 is, g2 is how much? G into 1 minus x. G into 1 minus x. This g is the acceleration due to gravity at the surface. Now let us simplify it. 1 minus x into 1 plus x square plus 2x is equal to 1. Let us expand it. 1 plus x square plus 2x minus x cube minus 2x square equal to 1. Plus 1 minus 1 is cancelling. Let us simplify it. It is x square minus 2x square minus x square minus x cube plus 2x minus x plus x is equal to 0 is equal to 0. Otherwise, x square plus x minus 1 equal to 0. Now it is in the form of quadratic equation like a x square plus bx plus c equal to 0. Then what is the x value? X value is right minus b plus or minus root over a square minus 4ac by 2a, b square minus 2ac, b square minus a, b square minus 4ac by 2a minus b plus or minus b square minus 4ac by 2a x equal to, right, now our equation, look at the equation. So we have the equation x square plus x minus 1 is equal to 0. Okay, then x equal to minus b minus 1 plus or minus root over b square. B square is 1 square minus 4a1 c minus 1 by 2a. X equal to minus 1 plus or minus, right, 1 plus 4 5 divided by 2. So it is equal to root 5 minus 1 divided by 2, right? But x equal to what? X equal to h by r. Then h equal to r by 2 into root 5 minus 1. At that height and depth, acceleration due to gravity remains same, or the weight of the body remains same. R by 2, look at the options. R by 2, R by 2, right? Okay, this can be written as R by 2 into root 5 minus 1. Okay, so option D is absolutely correct. Understood clearly? This can also be written like this. This can be also written as, this can be also written as, right, how it is written? It is written root 5 r minus r divided by 2. The same is given. Okay, option D is absolutely correct. Understood clearly? It is very important problem. Okay, similarly, let us take the another important problem. Look at this problem. It is assertion and reason kind of question. Assertion is given like this: the angular speed of the moon in its orbit about the earth is more than the angular speed of the earth in its orbit about the sun. Definitely, time period for the moon is approximately 27 days, whereas time period for the earth is, right, around 365 days. Then what is angular speed? Angular speed equal to, right, angular speed, time period t equal to pi by omega. The time period t equal to 2 pi by omega, or omega is equal to 2 pi by time period. From this I can say omega is inversely proportional to t. That means higher the t value, time period, smaller is the angular velocity. Since the time period for the moon is less, the angular speed maintained by the earth is more. That's what it is given as assertion. The angular speed of the moon in its orbit about the earth is more than the angular speed of the earth in its orbit about the sun. Assertion statement is absolutely correct. Look at the reason. The moon takes less time Yes, the moon takes less time to move around the earth than the time taken by the earth to move around the sun. Absolutely correct. The time taken by the moon is 27 days, whereas time taken by the earth is to revolve around the sun 365 days. So reason is correct, assertion is correct, reason is correct. Reason is giving the correct explanation for assertion. Therefore, the options, look at the options. A is correct, but R is not correct. No, look at the B. Both A and R are correct. And R is giving the correct explanation. Yes. B. Option B is absolutely correct. Understood clearly? Yes. Then look at the another important problem. Look at this problem. The acceleration due to gravity on the surface of the earth is G. If the diameter of earth is reduced to half of its original value and mass remains same, then acceleration due to gravity on the surface of the earth is, acceleration due to gravity on the surface of the earth is gm by r square. Gm by r square. If r is reduced to half of the value, r by 2, at constant mass of the earth, then what is the new acceleration due to gravity? G dash equal to g m by r becomes r by 2, whole square. It is equal to gm by r square. This 4 goes up, right? G dash equal to 4 times the gm by r square, but gm by r square equal to g only. Therefore, the new acceleration due to gravity is 4 times the acceleration due to gravity on the surface of the earth. Look at the option D. Option D is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. Two identical particles, each of mass m, each of mass m, go round a circle of radius a under the action of their mutual gravitational attraction. It is like this. Two particles. Let us mark the two particles. This is the one particle, this is another particle, maintaining the equal mass, and they are rotating such that radius of rotation remains same. That is A. This is A with respect to center of rotation. Let that center of rotation is O. Under the action of mutual gravitational attraction, the angular speed of each particle will be. What is the angular speed of the each particle? This gravitational attractive force is providing the centripetal force. Therefore, this gravitational force of attraction equal to G m m by, right, 2a plus a 2a whole square. It must be equal to centripetal force, that is m into a into omega square. Therefore, it can be written as g m square. Otherwise, one m is cancelling. One m is cancelling. It is gm by 4a square must be equal to a into omega square, or omega square equal to gm by 4a cube. Therefore, angular speed equal to root over gm by 4a cube. That is the answer. Gm by 4a cube. Look at the option C. Option C is absolutely correct. Very simple problem. Okay. Similarly, let us take the another important problem. It is asking like this. Two planets A and B of radii R and 1.5 R. Planet A and planet B. Planet B, planet A. Okay. The radius of the planet A, let it be RA, is given as R, and radius of the planet B, RB, is given as 1.5 R. Have densities rho and rho by 2 respectively. Density of the A equal to rho, density of the B equal to rho by 2. Their ratio of acceleration due to gravity at the surface of the B to A, right? So acceleration due to gravity, as you know, acceleration due to gravity for the A, GA, is equal to G m by R square, Gm by R square. Similarly for the B, GB equal to Gm by R square, R square. But as you know, the mass equal to density multiplied by volume. Density multiplied by volume equal to what? Volume equal to 4 by third pi r cube. 4 by third pi r cube. Then let us take another slide. The right G general formula, G m equal to density multiplied by 4 by third pi r cube divided by r square. Then G equal to rho into 4 by third into G into pi into pi into what right, pi into R. G equal to 4 by third G capital G into pi into rho R. You know, this 4 by 3 G pi remains same. Therefore, G is proportional to rho R. G is proportional to rho R. From that, I can write that G by rho R is proportional to 1, or G by rho R remains constant. Remains constant. So from that, I can write that G GA by rho A RA equal to GB by rho B RB. GA by GA by GB equal to rho A RA by rho B RB. For the density of the planet A, density of planet A is rho. RA is R only. RA is R only by rho B. Rho B equal to rho by 2. RB equal to 1.5 R. Rho B equal to rho by 2. 1.5 R. Then it is, then rho is cancelled. R is cancelled. Finally, it is 2 by, it is equal to 2 by 1.5. 1.5. But it is asking the acceleration due to gravity at the surface of B to A. B to A means GB by GA equal to 1.5 by 2. It is equal to 0.75 is equal to 3 by 4. 3 by 4. Therefore, GB is to GA is equal to 3 is to 4. That is the answer. 3 is to 4. Look at the right. Look at the options. 3 is to 4. No? 3 is to 4. Is it 3 is to 4 or 4 is to 3? 3 is to 4. Right? 3 is to 4. Therefore, option C is absolutely correct. Understood clearly? Yes. Similarly, look at the another important question. It is statement 1 and statement 2 type of question. Look at the statement 1. For a planet, with the ratio of mass of the planet 2, its radius increases, the escape velocity from the planet also increases, absolutely increases. Because escape velocity equal to root over 2 gm by r. If mass by radius increases, definitely escape velocity escape velocity also increases. So statement 1 is absolutely correct. Look at the statement 2. Escape velocity is independent of the radius of the planet. No. Escape velocity is depending on the right. Escape velocity escape velocity is right inversely is proportional to 1 by root r, and escape velocity is proportional to root m. From that you can say that escape velocity not only depending on the mass of the planet but also depending on the radius. So statement 2 is wrong. Only statement 1 is correct. Look at the option A. Statement 1 is incorrect. No. Statement 1 is correct, but statement 2 is incorrect. Option B is absolutely correct. Remember, the escape velocity is depending on both mass of the planet and the radius of the planet. Understood clearly? Yes.
Geobyte.